This graph illustrates the effects of first-degree price discrimination. Q, the quantity where marginal cost intersects the demand curve, maximizes profit. Q is greater than Qmax. I haven't marked Qmax on the graph, but Qmax is the quantity directly below point B where the marginal revenue curve intersects the marginal cost curve. Qmax is the quantity that maximizes profit when the firm does not discriminate in price. It's easy to see that Qmax is below Q. The first-degree price discriminator produces more output than the monopolist that charges a uniform price. In first-degree discrimination, every buyer pays the maximum price he is willing to pay for each and every unit purchased. This means total revenue is the price paid for the first unit, whatever that value is, plus the price paid for the second, plus the price paid for the third, the fourth, etc., on down to PQ, which is the price paid for that last unit produced. When output is continuous, total revenue will be the area under the demand curve. So suppose I can actually produce 0.0001 units of output. And what's the price we pay for that? 0.002, what's the price for that? If output's continuous, total revenue would equal all of the area under the demand curve from quantity 0 up to quantity Q. The engineers and mathematicians of you will recognize this as an integral under the demand curve. Profit, as always, is going to be total revenue as total cost. We've got total revenue, it's the sum of the prices paid for each and every unit. Total cost is output times the average total cost at that last unit of output. This profit will be higher than the profit when the firm charges a uniform price. The profit when the firm charges a uniform price is Pmax. Let's scroll up and look at this a little bit. Pmax. Pmax will be the price charged at Qmax. Pmax is the price on the demand curve just above B. So it'll be right where my cursor is right now, about where Pmax is. The price the firm charges when it maximizes profit at a uniform price, minus the average total cost that it pays when it produces Qmax, times Qmax. And this profit is going to be less than the profit earned when the firm engages in first-degree price discrimination. Let me give you an example. The following table shows the demand curve for a product. The demand curve shows the quantity demanded at various prices. So if you give me a price, I can give you the quantity demanded. When price is 8, for example, the quantity demanded is 3. It also shows the highest price a consumer is willing to pay for each unit of output. Somebody's willing to pay $10 for the first unit. Once I've sold the first unit, somebody else is willing to pay $9 for the second unit. Once I've sold the second unit, somebody's going to pay $8 for the third unit, and on down the table. Suppose further that average total cost is constant at $2.50 for all levels of output. Well, I've got a couple rows here. I've got to get two more columns. I've got two more columns. The next two columns show me what happens without price discrimination. I'll have total revenue and I have marginal revenue. Total revenue is price times quantity. So total revenue goes 10, 18, 24, 28, on up like that. Marginal revenue is the extra revenue generated when the firm produces and sells the extra unit of output. So if I don't sell any output, my total revenue is going to be 0. If I sell the first unit, my total revenue is going to be 10. So the marginal revenue will also be 10. When output goes from 1 to 2, total revenue rises from 10 to 18. So the marginal revenue is only $8, and on down then we go to 6, 4, 2, etc., etc. With price discrimination, when I sell only one unit, I'm going to charge that buyer the highest price he or she's willing to pay. So I'll capture $10, and again the marginal revenue will still be 10. But now what happens when I sell the second unit? In first-degree price discrimination, I still charge the first buyer the most he or she's willing to pay. So I'm going to get that $10, and now I'm going to pick up the $9 the next buyer is going to pay for the second unit. So total revenue goes from 10 to 19. Marginal revenue goes from 10 to 9. When I sell to the third buyer, I still get 10 from the first buyer for the first unit. I still get 9 for the second unit. Now I get 8 for the third unit. So total revenue goes from 19 to 27, and marginal revenue goes to 8. With first-degree price discrimination, marginal revenue and price are identical. That's why the first-degree price discriminator maximizes profit where the demand curve crosses the marginal cost curve. Let's answer some questions. If the firm does not discriminate in price, it maximizes profit by selling 4 units of output. So the firm wants to sell the first unit because marginal revenue 10 is higher than 2.5. It wants to sell the second because marginal revenue 8 higher than 2.5. It wants to sell the third because marginal revenue 6 is higher than 2.5. And it wants to sell the fourth unit because marginal revenue of 4 is higher than 2.5. It does not want to sell the fifth unit because the marginal revenue is 2, and that's below the marginal cost of 2.5. So quantity 4 maximizes profit when the firm does not discriminate in price. The highest price people are willing to pay at that level of output is 7. So 7 is the profit maximizing quantity. 4 is the profit maximizing level of output. And we do some math to find the profit. Price minus average cost times output gives me a profit of $18. Now what happens when the firm engages in first-degree price discrimination? Now the price and marginal revenue are identical. So the firm wants to sell the first unit, the second, the third, the fourth, the fifth, the sixth, the seventh, the eighth, because all of them have price or marginal revenue above the marginal cost of 2.5. It does not want to sell the ninth unit because there it only gets extra revenue of $2 and it pays an extra cost of 2.5. So with first degree price discrimination, the profit maximizing quantity is 8. It charges various prices. Profit is going to be total revenue less total cost. Let's scroll down here. So total revenue is going to be 52. We can find total cost by taking average total cost times output. So 52 minus 20 gives me a profit of 32. Profit goes from 18 with a uniform price to 32 with a in first degree price discrimination. That increase in profit is the reason firms would love to be able to practice first degree price discrimination.